And just as a side note, in Amazon, if you look at the 5-star ratings on Bringing Nature Home, 87% of the people give it 5 stars. And as a comparison, To Kill a Mockingbird, which is probably the greatest novel written in America, only gets an 82%. So you have beat To Kill a Mockingbird. Who would have thunk it? I've heard Dr. Tallamy speak 4 times, every time I've gone home and I've cut something down in my yard. Afterwards, because I sit here and I go, oh, I don't need that plant. So as I was driving off today, the sawtooth oak was looking like, uh-oh. She's going to come back. I'm not going to go into the whole bio. You can read that on your program. Dr. Tallamy is awesome, and we will just let him get to it right now. Oh, before we start though, if you have one of these, turn it off.
Well, thank you, Marilyn. It's good to be back in Oklahoma City. I'm not in Oklahoma City. In Oklahoma. I will be in Oklahoma City. Right. Actually, I was here, they tell me 5 years ago, and I started meeting people in the hall, and they said, have you ever been to Oklahoma before? And I said, no. And then I met somebody else, they said, welcome back. I said, well, maybe I have been here. Yeah, I don't have very good memory. Okay, we can talk about creating living landscapes. I always fool around with the titles. A Chickadee's Guide to Gardening. I'm thinking of 50 Shades of Green. Get your attention, but I'm going to start by asking you what this bird is. Resplendent quetzal. Resplendent quetzal. This is an endangered bird in the forests of Central America, and it's endangered because it has a very, very specific diet. If you don't have fruits of the wild avocado tree, you don't have resplendent quetzals. It's not the only thing they eat, but it's a major part of their diet. And unfortunately, we have cut down most of the wild avocado trees. So we figured out that if we actually want quetzals in our future, we have to plant wild avocado trees. And that's what these young ladies are doing here. Now, fortunately, these trees grow pretty quickly. They reach the age at which they reproduce in not too many years. And it's starting to look better for the future of quetzals. But that same conservation scenario can be repeated time and time again, particularly in the tropics. If you want to save the great green macaw, you have to have mountain almond trees, because that's the only tree they will nest in. Now their future's not so bright. There's not very many birds left, and it takes 150 years for the mountain almond trees to reach the stage at which they'll use it. If we want to save jaguars, we have to have particular species of palm trees. Why palms? Because they make a particular type of palm nut. And that happens to be the favorite food of peccaries, which is the favorite food of jaguars. So we're talking about specialization in the natural world, particularly focused on food webs. And it's the rule, it is not the exception, and it always starts with plants. Now most people think you get all that specialization in the tropics because there is so much specialization in the tropics. But we actually have a great deal right here in the temperate zone, and some of the most specialized relationships that have ever evolved occur right in our yards. This is one of them. This is the Ebola Spider. It's a female. She's hanging from a river birch leaf in my yard. And it's obvious why she's called Ebola Spider. She drops a single strand of silk and puts one sticky glob of glue at the end of it. And it looks very much like a bolus. Now she doesn't swing it around her head like this, but she does go fishing with it. She lowers it and raises it and lowers it very slowly. And the first time I watched her do that, I told her, you are not going to catch anything. Because that's the way I used to fish, and I didn't catch anything. But about 15 seconds later, a moth flew in and got stuck on her little sticky glob of glue, and she reeled it in and actually laid her eggs on that. Now what I didn't know at the time is that that was not an accident. That spider was releasing the sex pheromone of that particular species of moth. She had mimicked it. And was releasing the precise pheromone, and each species of Ebola spider in the world mimics the sex pheromone of a single species of moth. Wow. So you can have Ebola spiders in your yard if you have the host plant that supports the larval development of the particular moth that Ebola spider is specializing on. This is Foxy Barricade, a very common spring ephemeral, at least back in the east, and it spreads readily by seed, but only if it's pollinated. But if you think about pollinating flocks, I mean, look at the tiny entrance to the corolla. Who is pollinating our flocks? I've watched native bees land on there and try to get their mouth parts into that hole, and they can't do it. It's too small. But if you watch your flocks carefully, you'll see that these day-flying sphinx moths are the primary pollinators. That's the tongue right there. This is a snowberry clearwing. He buries his tongue straight into the corolla, pulls it out. It's now really covered with pollen. Then he flies to the next flower. So if you can get your flocks pollinated, make lots of seed if you have day-flying sphinx moths like the snowberry clearwing. And you can have snowberry clearwing adults if you have snowberry clearwing larvae. And you can have snowberry clearwing larvae if you have coral honeysuckle, because that's their host plant. Even animals we don't think of as having specialized relationship with plants actually do, at least at some part of their life history. And I'm going to use the Carolina chickadee as an example. We all think of chickadees as seed eaters, because they do eat seed. They eat seed at our bird feeders all winter long. But when it comes time to make more chickadees, they don't eat seeds anymore, they eat caterpillars. And it's not because caterpillars are the only things they could find. They could take early season grasshoppers or early season crickets or mayflies or caddisflies or serpent flies or snipe flies or cicadella leafhoppers or tree hoppers or cassidine tortoise beetles or click beetles or sow bugs or millipedes, centipedes or millipedes or spiders. All of those things are around when chickadees are hunting for their young. But they don't take those guys. They ignore them and they take caterpillars. Which means if you're in an area where there are not enough caterpillars, you're not going to be able to have breeding chickadees. So that's the next question. You know, almost enough caterpillars isn't good enough. You've got to have enough or the chicks won't make it. How many is enough? How many caterpillars does it take to make one clutch of chickadees? Well, it takes a lot. And it was these birds that told me that. I put up a little nest box in my yard, and they built their nest in there. And then I set my camera up so I could see what they were bringing back to the nest. And even though everybody else already knew this is when I learned about chickadees. First thing I learned is that yes, they bring back caterpillars, and they bring them back quickly. The male and the female chickadee cooperate when they're breeding, and they can bring a caterpillar back to the nest once every 3 minutes. In one 27-minute period, they brought back 30 caterpillars. So how do they do that? By bringing back more than one at a time. Sometimes a whole bunch. And they do this all day long, 6 a.m. to 8 p.m. Now, another thing we need to think about is how many species of caterpillars are they bringing back? In a 3-hour period, they brought back 17 species of caterpillars. You have to remember that if you put up a chickadee box, they're going to forage about 50 meters around the nest. They don't fly 5 miles down the road to the nearest woodlot. So if you don't have what they need right near the nest, they're not going to be there. So 17 species in 3 hours. Why is that important? That's important because if I had 1 or 2 species of caterpillars in my yard, and it happened to be a bad year for caterpillars, like this year, at home, this is a bad year for caterpillars. We're seeing very few. Well, those 2 species wouldn't be numerous enough, and the chickadee nesting would fail. That food web would collapse. But if I have 34 species or 134 species, and actually have a lot more than that, there will always be some combination of caterpillars that are common enough so that they'll be abundant enough and the chickadees can reproduce even in a bad year. So this is a case of diversity in the food web stabilizing that food web. Diversity creating stability. All right, we can go to the book and actually look up how many caterpillars a chickadee will bring back to the nest every day. And depending on the number of young in the nest, it's between 390 and 570. And they do that on average for 16 days until the young fledge. And then they actually feed the fledged young caterpillars afterwards, but then we can't follow them, so we don't know what happens then. So you can get out your calculator. That's between 6,000 and 9,000 caterpillars required to make one clutch of chickadees. And chickadees are tiny birds, 1/3 of an ounce. What if we wanted to make a red-bellied woodpecker? It's 8 times heavier than a chickadee. How many caterpillars does that take? And of course, we don't just want chickadees and red-bellied woodpeckers in our yards. We want scarlet tanagers and titmice and blue jays, and we certainly want our bluebirds and our tree swallows and our yellow throats and indigo bunnings and towhees and yellow warblers, whatever that is, wood thrush, cardinals, hummingbirds. You know, these are all common birds. They're common birds, or we want them to be common birds in our neighborhoods. Think of the tremendous number of caterpillars required to have that community of birds. Speaking of specialized relationship, what's a specialized relationship with hummingbirds? Nectar. No. Yes, that's what I wanted you to say. But no. 80 to 90% of a hummingbird's diet is insects and spiders. They do go to our nectar feeders, but they can't live on sugar water. They need protein, they need fats. And that is true for 96% of the terrestrial birds in North America. This is a list of bird families that rear their young on insects, and the book will say other arthropods. And those other arthropods are typically spiders. But what do spiders eat? They eat insects so they can become spiders. So it's really all about insects. Which means, if we don't have insects, we're not going to have any baby birds. This is news to a lot of people. A lot of people think that birds need seeds and berries. And you can pick up almost any Landscape for Birds book, and that's what it'll talk about, how to put plants in your yard that make seeds and berries. And then, that's good, but we also have to put the plants in our yard that make the insects that actually create the birds, because that's what they're using when they breed. All right, what types of landscapes do that? What types of landscapes are capable of producing the abundance and the diversity of insects that we're talking about here? And to answer this question, I've got to talk about the most common type of specialized relationship that you can find anywhere. And that's the relationship between the insects that eat plants and the plants themselves. So we're not talking about pollinators here. We're actually talking about things like these caterpillars. You have to remember that plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they have loaded their tissues with nasty tasting chemicals. Secondary metabolic compounds that make these tissues either bitter or downright toxic. And it's a really wonderful defense. It keeps most of the insects of the world from eating most of the plants of the world. And that's why we can look out the window and it's green. It's not because there's nothing out there that wants to eat those plants. It's that most of those plants are so well protected they are unavailable to the insects that want to eat them. But we do know that insects eat plants. So how do they do that? How do they get around these chemical defenses? Well, they specialize. 90% of the insects that eat plants are what we call host plant specialists. They can only eat the plants for which they have developed specialized adaptations over evolutionary time that allow them to get around those chemical defenses. Let's use eastern red cedar as an example. It's a conifer, of course, which means it's very old. It's many millions of years old, and it has been interacting with local insects in our landscapes for many millions of years. Yet there are still very few insects that have the ability to eat eastern red cedar because it's well protected by a toxic monoterpene, Beta-thuya-plixin. But this is one insect that can eat it. This is the Juniper Hairstreak. It is a host plant specialist on red cedars, which means it can eat Beta-thuya-plixin without dying. It's got all the physiological adaptations, the enzymes, the behavioral adaptations that allow it to get around that defense. And that's the upside of specialization. The downside is, now that's all it can eat. Which means if we don't include red cedars in our landscapes, we're going to lose that butterfly. It no longer can eat, milkweeds or anything else. If you're going to eat eastern red cedar, you might as well look like it. There's the larva right there. And there are several species. The ones that do eat red cedar all look a lot like it. This is the caterpillar right here. There it is up close. That's the curved line angle, another cedar specialist. Here's one right here. I showed this picture to my wife and I said, "Can you see the caterpillar?" And she said, "Of course." And I said, "Yeah, this guy's easy to see because he's actually backwards. That red head is supposed to be against a red stem over here." And she said, "Well, I didn't see that one. I saw this one that I hadn't seen when I took the picture." You can even mimic the dead parts of red cedar. This is the Juniper geometer right there. It's a relatively common moth. You can look for it on your cedars. So fun with crypsis, it's another advantage of being a specialist. You can look like what you're eating so that all those birds that are trying to find you have trouble finding you. Although when I was watching my chickadees, they were bringing back those cedar specialists. They couldn't find them. I couldn't, but they could. Today's world, though, specialization has become a curse. Because we humans are manipulating our landscapes so much, we are taking away the host plants of so many of these insects. And nothing illustrates it as well as the monarch butterfly. Most of you are aware that monarchs are in trouble. They are specialists on our milkweeds. And quite simply, we've taken milkweeds out of most landscapes, particularly in agriculture. And not this year, not this past winter, but the winter before that, there were only 3.6% of the monarchs left compared to 1976. So that's a 96.4% decline. Now we can follow what's happening to monarch butterflies because we can go down to their overwintering site and actually count them. Hard to do that with other insects, but you can imagine what's happening to them. It's largely clean farming techniques that have devastated the monarch in the Midwest because we get Roundup Ready corn and soybeans, where of course you can spray the herbicide over the crops, doesn't hurt the crops, and it kills the weeds. But you know, getting rid of the weeds in the crop, I think that's fair enough. If I were a grower, I'd want to do that. But this is the problem over here. We're also spraying everything outside of the crop. So what used to be what we call weeds on the side of the field are now, they're now dead. So this is where the milkweed was, this is where the asters were, this is where all the blooming plants that supported the rest of life in the Midwest used to be. And part of the problem is we've got a marketing issue here. If we call everything except our crops a weed, like milkweed or Joe Pye weed or New York ironweed, every native plant is a weed. We got to rename them. How about Milky Beauty or something? Then we think, oh, maybe we should keep that plant around. But so I think it's just overuse of the product that's really devastated the monarchs. And until we adjust the way we are conducting our agriculture, where's the monarch going to survive? It's going to survive in our neighborhood gardens. That's where. So plant as much milkweed as you can. It's not just caterpillars that are specialists. Again, 90% of the insects that eat plants, this is the elderberry beetle, only eats elderberry. The dogbane beetle only eats dogbane. Sumac flea beetle only eats sumac. This is a leaf-footed bug, a Korean bug that only eats ash. So if the emerald ash borer comes and kills all your ashes, like it's doing farther north and to the east, we will lose this insect. Dave Wagner just finished a paper re-examining the number of insects that are specialists on ash. He's up to 96 that would disappear if we lost our ashes. And that's because of that host plant specialist, that 90%. Got to remember that figure. We can use this knowledge, though, the fact that most insects are specialists, to actually rebuild food webs that once existed in our landscapes. We can put them back simply by putting the appropriate plants back. But we have to understand what these food webs are comprised of. Who's a member of a particular food web? And I'm going to give you an example of how this might work. Let's look at the food web of the white-eyed vireo. I'm choosing the white-eyed vireo because that's the nest that my wife found in our yard a couple of years ago. It was low enough, so again, I could set my camera up, I could take pictures of what these guys are bringing back to their babies. Then we could work backwards. We could know what the caterpillar ate and know what plant we need to support white-eyed vireos. So let's do that for a while. This caterpillar right here is the blinded sphinx moth. It's a specialist on black cherry. And we do have a lot of black cherry at home, making blinded sphinx moths so the babies get to eat. This little guy here is the chestnut caesura, and despite its common name, it's a specialist on native viburnums. At our house, that's Viburnum dentatum. Our property was mowed for hay before we moved in, so we know the plants that are there. And the viburnums that we have put back are Viburnum dentatum, arrowwood. And we've got them so it's making chestnut caesuras and the babies get to eat again. This guy is the drab prominent, a specialist on sycamore. By now you think I'm just making all this up, but this is how we do this. You can tell there are key characters on all of these caterpillars that help you identify them. See the two little anal prolegs right there, little projections sticking out the rear end? There's only one family of moths that has these projections. That's the family Notodontidae, the prominents. And there's only one species of prominent that has a white stripe down its back. So even I can figure that out. That makes it the drab prominent. We have sycamore in our house because years ago, probably the second year after we moved in, I had a cold frame in the backyard and we had a really windy night. And sycamore seeds blew in from who knows where. It was a long way away. One landed in the middle of my cold frame and germinated. and I am not very fast at weeding things out. It's now about 40 feet tall. And it's making drab prominence, and the vireos get to eat again. This guy's the 8-spotted forester moth, specialist on native grapes. This is the lunate zale, another specialist on black cherry. So black cherry is becoming important in this food web. This guy's the Spicebush Swallowtail. There's this little eye. It's supposed to scare the bird into thinking it's a tree snake. It didn't work this time. Of course, is a specialist on spicebush or its close relative sassafras. We have both of them. This guy's the tufted bird-dropping moth, another specialist on black cherry. So black cherries really become important in their food web. But these little chicks are hungry. They need a lot more than that. So let's put some black walnut into the landscape. We can get the walnut sphinx. We can get the gray-edged bomoloka, the black blotch caesura. We can get the bride. These are all specialists on black walnut at my house. Native maples will give us Plagotes inchworms and green striped maple worm and the retarded dagger moth. Native elms, this is the American elm, give us four-horned sphinx, the double-toothed prominent, the white-lined senior moment moth. Snout, the white-lined snout, yes. This is the mustard sallow. You'll get that on witch hazel. Violets, you don't put violets in your lawn. They're typically there. And what do? They come up in the spring and we mow them down. Well, where I come from, that's the only host plant of our true fritillary. Gulf fritillary, by the way, is not a true fritillary. So things like the great spangled fritillary, the Rigo fritillary. You have the Rigo fritillary in Oklahoma, right? Yep. They develop on violets, but they overwinter as larvae. The eggs are being laid right now. They hatch in a week or so, and then these first instar larvae spend the entire winter in the duff waiting for the violets to grow up in the spring. Then they crawl up on the violets, and we chop their heads off with the mowers. So if you want fritillaries, keep a patch of violets. Again, remember, 90% of those insects that eat plants aren't going to be there if you don't have the plants with which they have co-evolved. So if you want hackberry emperor, and I believe we've got some in the other room there, you need hackberry. If you want Cuculio asteroides, you need native asters. If you want the brown hooded owlet, you need goldenrod. If you want the hog sphinx or the Pandora sphinx or the abbot sphinx, you need Virginia creeper. The river birch dagger moth requires river birch, believe it or not. The zebra swallowtail, pawpaw. Redbud leaf roller requires redbud. Large pectes only on sweet gum. The white furcula on native willows. Turbulent phosphilla on greenbrier. The orange tufted oneida. The spiny oak caterpillar. Two-spotted oak punky, the variable oak leaf caterpillar, the red-humped oak worm, the pink-striped oak worm, the lesser oak dagger moth, the greater oak dagger moth, the afflicted dagger moth, the pleasant dagger moth, the delightful dagger moth, the epilated dagger moth, the streaked dagger moth, the white-blotched heterocampa, the oblique heterocampa, the red-lined panapoda, the laugher, and many, many more will be there only if you have oaks. Oaks are really important. Why do we want all these insects? It's not just for the birds. Birds need them, but so do some of the other things. We talked about spiders. Spiders, of course, eat insects, or they eat other spiders that eat insects. A lot of people don't like spiders. I'm actually one of them. When I was little, my friend used to throw them at me. I don't want them on me. But look who does like spiders. It's the second most important component of bird food webs. You can't get rid of the spiders or you'll lose the birds. Then we have all these insect predators, the things that are eating the insect herbivores. They would disappear without the insect herbivores, which means you'd lose our frogs, you'd lose the toads, you'd lose all of the amphibians because they all eat insects. Our lizards, our bats, our rodents eat insects. A lot of people think rodents eat seeds. They do, but when they can't find them, they're only eating the seeds when they can't find the insects, because insects are such good food. Pound for pound, some studies have shown twice as much protein in insect meat as there is in beef. And insects have fat bodies in their abdomens. It's an organ that produces a lot of lipids, which allow these little guys to grow quickly and reproduce quickly. And if you're a mouse, that's what you want to do, because there's a lot of things that want to eat you. But for the same reason, larger organisms eat insects too. The skunk is digging up your yard to get the grubs that are in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. And even things we don't think of as insectivores eat a lot of insects. Like our friend the red fox, 25% of a red fox's diet is insects. 23% of a black bear's diet is insects. And even things that don't eat insects require insects. This is a sharp-shinned hawk. It's a bird predator. You might think, well, we can get rid of all the insects in our yards and still have sharp-shinned hawks in our neighborhoods. But think about it. The birds this guy's eating needed insects to become birds. So it needs insects indirectly. Same thing with the garter snake. It's not eating insects directly, but it's eating the frogs and the toads that ate the insects. We cannot remove insects from our world without losing biological diversity, without humans. That's why this is important to everybody, not just the choir, not just people who like life. We all need the diversity of life on this planet, or we're going to disappear ourselves. What is happening to species that directly eat insects? Well, for most of those species, nobody's measuring it, but we do measure birds because we like birds. We had the State of the Birds report come out in 2014, September, so almost a year ago. 230 species of North American birds now at risk of extinction. Now 50% fewer songbirds today compared to just 40 years ago. As a matter of fact, there's a statistic from the World Wildlife Fund. There's 50% fewer animals of all kinds on this planet than there were not very many years ago. So other life forms are disappearing. That's not good news. Why is that? Why can't the biodiversity that we want to be out there be sustained in our parks and preserves? We do have parks and we do have preserves, but they're not doing the job. Well, there's a couple answers. The simple one is that they're just too small. They're too small. When you take a large area like this and you shrink it down to a small little habitat patch, and it doesn't have to be that small, you're taking large populations and shrinking them down to small or tiny populations. And that's the problem. Small populations are highly vulnerable to local extinction. Why is that? Because all populations fluctuate. In good times they go up, and in bad times they go down. If you have a large population, this top line here, even in its down cycle, there's enough individuals so that when times get better, it can rebound quickly. The problem is with tiny populations. When there's only a few of them, often in their down cycle, they disappear. They blink out of their little habitat patch, and then they're gone. And unless they recolonize that patch, and so many of our animals can't recolonize things because we've got the world so carved up with roads and highways and everything else, then they're permanently gone, and that's called local extinction. And studies from all over the world are showing, and some of these studies are quite lengthy, 100 years in length, are showing that the natural areas we have left are not large enough to sustain the nature that we need them to sustain. And unfortunately, that includes our largest national parks. Not only have we chopped up the world in these little habitat fragments, but we've also introduced a lot of non-native plants. 3,300 was the last count that I saw. And they are, they're what we call invasive species. They are now invading or have already invaded these habitat fragments. A third of the vegetation in these habitat fragments in so many parts of the US is not native. Typically it's from Asia. This is a park that I pass on the way to work, when I go to work. It's called White Clay Creek State Park. It's one of those habitat fragments we're talking about. And this is what it looks like in the spring. In the spring, I don't know if you've noticed, but plants from Asia leaf out before the plants from North America. They're not phenologically on the same wavelength. So what you're looking at there are all plants from Asia. None of what you see green there is a native plant. We got multiflora rose and Oriental bittersweet and Japanese honeysuckle and bush honeysuckle and ailanthus and Norway maple and Bradford pear. They're all there. They're all escapees from our garden, by the way. And that's what the vegetation is. That's the first trophic level in that park. So there's a big problem there. We can measure what happens when we replace these native plant communities with plants from someplace else. In other words, when we disrupt those specialized relationships I was talking about earlier. And we've done this very formally, common garden experiments, published in a number of journals. But I'm going to share with you something you can do at home, which will demonstrate the same result very well. I call this my 12 by 12 experiment. If you mark out 12 feet by 12 feet on your front yard, that's pretty much what it's going to look like. You get to determine how much diversity, how much biological diversity can live in that space. If you keep it as lawn, you can get on your hands and knees and count how much diversity is there. And then mow it, and there won't be anything there. Or you could put a white oak in that space. Around here would be a bur oak, I guess. And that's what we have here. So this if you walk around this white oak, it's about 12 by 12 feet. This is an oak in my yard that I planted from an acorn. It demonstrates two things. Oaks grow. You don't have to buy the 15-foot oak for $2,000 and then watch it die because it's so root prune. You can put in an acorn, and if you protect it from the deer, it will grow. That's about 25 feet tall now, and it's 15 years old. 14 years old when I took that picture. All right, so there it is. It's in our 12 by 12 foot section. Walk around the outside, and at head height, count the caterpillars. And that's what I did last year, July 25th. I got 410 caterpillars from 19 different species. There they are. And then I stood back, took that picture, just to demonstrate you can't see any of those caterpillars. It's not defoliated. Yet if I knocked on somebody's door and said, hey, you've got 410 caterpillars on your tree, they'd be out there with a spray can, gotta save the tree. And this is the distance at which we view most of our trees. We don't have a clue how many insects are actually on there, and the tree is doing just fine. Okay, then I went to a black cherry. There's a black cherry about the same size. Walked around it, 12 by 12 section, counted the caterpillars just at head height. I got 239 caterpillars from 14 species. Then I went to my neighbor's house, and I counted what was on one of his Bradford Pears. Now, he moved in the same month we did. So he's been there the same time. These trees are the same age, about the same size. First thing I had to do was figure out which Bradford pear I was going to count, because he's got 32 of them. Well, I counted that one, and I did find a caterpillar. I found one inchworm from one species. Then I moved over to his whole row of burning bush, counted a 12 by 12 foot section, and I got one species, 4 caterpillars from one species. They're leaf skeletonizers, which are too small for a bird to eat. Okay, what if I just happen to pick a really productive white oak and black cherry and really unproductive burning bush and Bradford pear? Let's do it again on July 26th with different plants of the same species. This time I got fewer. I got 233 caterpillars on the white oak, 53 in the black cherry, 2 in the burning bush, and 1 again on the Bradford pear. So what's emerging here is a pattern. It's a pattern. The productive native plants are what's supporting the life in your neighborhood. And these plants from Asia aren't. And you can measure it as many times as you want in many different places. You're going to get the same pattern. I was driving back from a talk in Williamsburg this spring up the eastern shore of Maryland, and I got to the Sunset Beach Inn and Grill. And here we have the Bradford pears. They're all in bloom, and these are pretty old. They've obviously been there for a while. And obviously that is what the Sunset Beach Inn and Grill decided to landscape with. Okay, I kept driving, and right past the Sunset Beach Inn and Grill was a field, and it was 100% invaded with the offspring of those trees. I don't know how many acres that is, because it kept going, for a while. And that's the problem. That's the other problem with Bradford pear. Highly invasive. This is what an invasion looks like. So now these guys have turned this field into a mass of Bradford pear producing 1 caterpillar. There won't be any chickadees breeding in that. So you can say, well, they've got the right to landscape any way they want. And maybe they do. But do they have the right to biologically pollute all that acreage that they don't own? Or even if they do own it, do they have the right to do that? That's the philosophical debate that we're having right now about landscaping. All right, how different can plants be at supporting food webs? Well, I'll just give you a very, very simple example of some extremes. But many of you know we created this list a while ago. This is all of the woody plant genera that you can find in the mid-Atlantic states. We have a list of all the herbaceous genera as well, and the little numbers in parentheses after each plant genus are the number of species of caterpillars, of Lepidoptera, that are recorded as using those plants as host plants. So memorize that. This has become a popular list. This allows us to rank. We have the best plants over here and the ones not doing so much over here. To rank them in terms of their usefulness in food webs. So if you really want to restore a piece of your property or your whole property, which plants are going to work for you? Okay, but now people say, well, this list is for the Mid-Atlantic states, not for Oklahoma. You're right, but the Forest Service has given, through the National Wildlife Federation, has given our lab some money, 1 year's worth of my technician's salary, so she can make a list like this for every state in the union, actually for every county in every state. And she's almost done. It's going to be launched on the National Wildlife Federation website in January. And we're supposed to get the data to them by September 1st, so I'm not going home because it's not going to happen. But anyway, you'll be able to look up your county and get a ranked list of the most productive plants as recorded by the literature in your area. So it should be a big boom. But I predict that in areas where oaks grow, they're going to be number one. There's something about oaks that really makes them popular with caterpillars, so it makes them very important in food webs. In the Mid-Atlantic, 557 species of caterpillars recorded on oaks. Now let's compare that to ginkgos. Ginkgo biloba from Asia. I'm picking ginkgo because, urban foresters are pushing ginkgo now. They say ginkgo is going to be the future tree of our cities because it's an extremely old lineage and it has already withstood all kinds of climate changes in the past. So therefore, it'll withstand the current climate changes. Okay, and then you'll have a tree there. But what's that tree doing? It's supporting 4 species of caterpillars, and I think every one of those is a host plant record mistake. Mistakes do happen. One of those species is supposed to be the Cecropian moth. If you've ever reared Cecropian moth or watched them, you know that they eat at our house, it's always black cherry, and then they often crawl off the plant. They'll crawl a while until they find a place where they can spin their cocoon. I have a Cecropian moth cocoon on my back porch right now. It wasn't eating my back porch. I bet you somebody found a cocoon on a ginkgo and said, aha, here's a good host plant, when in fact it really wasn't eating it. I'm going to track down the other species and see what they were, but I have never seen any feeding damage on ginkgo. But even if those are good records, 4 versus 557, which do you want supporting your food webs? Number 2 on the list is our native prunus. Things like black cherry and pin cherry and Chickasaw plum and American plum. 456 species of caterpillars on our cherries. Let's compare that to Zelkova, another common street tree being pushed, again from Asia. I guess because it looks like the elms we lost to Dutch elm disease. 0 caterpillars on Zelkova. So, it could be silk, it could be plastic, and it would look the same and be contributing just about as much. Probably the most common foundation plant in the country is probably Pieris japonica. We do have a native Pieris, but it's not very productive. Only 2 species recorded on it. We could put a native viburnum in that has 103 species recorded on it. So these are just examples of the way we could landscape and support food webs versus the way we typically are landscaping. So I'm trying to get people to think about the plants in their yards as if they were bird feeders. So there you go, they're bird feeders. Now you get to decide how much you're going to feed the birds. You can have a lot of bird feeders, or you can have just a few. The decision is yours. You can put seed in your bird feeders, or you can have empty bird feeders. There's the ginkgo right there. It's a big tree, but it's empty. So again, you get to decide. And we're not fooling the birds. I have a PhD student working in the suburbs of Washington, D.C., looking at chickadees. She's following 92 pairs of breeding chickadees. And this, a little hard to see, this blue line here is the territory in which one pair was breeding. The star is where the nest was. And this is where they were foraging for their babies. And these light blue and dark blue areas represent 90% of their foraging effort, 95% of their foraging effort. In other words, those are the plants in which they're looking for food. The dark blue areas are the ones where they spent the most time looking. So let's see what they are. They're all native plants. Basswood, sweet gum, pin oaks, willows, black cherry. This big one here was an American elm. Equally informative here are the plants that chickadees were not going to. So here we go, Japanese maples, silk tree, ginkgos, saucer magnolia, leyland cypress, crepe myrtles, black poplar, all plants from Asia. And why would a chickadee go there? You know, chickadees aren't born knowing a native tree from a non-native tree. They do go into these trees and they look around, nothing there, so they don't go back. It's just as if you were shopping and you went into Giant, is that a food store around here? Whatever you go into, and all the shelves are bare. How many times would you go back? You wouldn't. This is the result of that. My student's Desiree Naranjo, and this is a nest, a chickadee nest, and after she removed the 3 dead babies, she saw what the parents had been bringing back. They're sunflower seeds from somebody's bird feeder. The chickadees didn't have enough caterpillars to feed those babies, so they started feeding them seeds. The babies can't eat seeds, so they died, and that's the consequence of not having enough food in your local food web. Another really important part of her study is to look at the migrating birds that move through those suburbs. Migrants come and they hit the Gulf Coast and they move up through the country in a wave that goes just about everywhere. They're not following discrete lines. So when they get to a city, they move through the city. So really, you don't have to save biodiversity for a living. A lot of people do, but you don't have to do that. But you should consider saving biodiversity where you live, because your piece of property is an important component of your local ecosystem. And there's now too many of us for us to be all opting out of local ecosystem functioning. Let's talk briefly about berries, because so many people do plant plants for the berries. Many of the invasive bushes in particular that we have planted from Asia have been planted specifically because they make berries and the birds do eat them. So people say they're good for the birds. Well, let's look at that. You know, the relationship between plants and birds is another very specialized relationship. It's developed over the eons. Plants are making seeds. They want the birds to take those seeds away, to disperse those seeds, so they put a nice juicy berry around the seed, and then that's what the birds do. So that's a very useful, beneficial relationship for both the birds and the plants have made the berries with nutritional value that the birds need at the time that the plant wants the seed dispersed. So if they want their seed dispersed in the summertime, they make berries that are high in sugar. Things like our blueberries or the service berries that we have, elderberries. They're all high in sugar, good summer plants for our birds. These come ripe after the fledglings have left the nest. They've been eating nothing but protein and fats during their development. So now they need a high dose of sugar. In the fall, though, it's just the opposite. In the fall, birds are migrating and they need berries that are high in fat to fuel that migration. Or if they're going to spend the winter and not migrate, they need berries that are high in fat to get them through the winter. So plants our native plants are making berries that are high in fat. Poison ivy is one of the best plants for birds. Those berries are really great for those migrating birds. And then later on in the winter, many plants have berries that need to be frozen several times before they're palatable for the birds, and they start to rise in sugar value again as the birds near the end of the winter and are going to start breeding. So that's the typical sequence of nutritional value of our native berries. There's a woman called Susan Smith who recently got married and moved to Cornell, and I don't know what her third name is at this point, but she has been analyzing the nutritional value of berries, both of native plants and of non-native plants. And here's an example of what she's found. The native plants in the fall are producing high-fat berries, of course. You know, America pennsylvanicum, 50% fat. Native viburnums, almost 50% fat. Spicebush, 48%. Our native cornus, dogwoods, 35%. Virginia creeper, almost 24%. So high fat value, just the way the theory predicts. Look at the non-native plants that are producing berries in the fall. Multiflora rose, less than 1%. Bush honeysuckle, Japanese honeysuckle, less than 1%. Buckthorn, 0.5%. Ugly Agnes, 2%. Oriental bittersweet, 2%. In other words, these berries are high in sugar in the fall when they need to be high in fat. So what's turning out here? Now she's got to do more work. There's more species she has to look at. But the pattern that's emerging is that the plants we brought over, the berry-producing plants we have brought over from Asia, are phenologically out of sync with the needs of our North American birds. They are producing high sugar berries in the fall instead of in the summer. Our birds eat those berries. And you might say, well, why are they eating high sugar berries when they need high fat berries? And the answer is for the same reason we eat high sugar everything when we don't really need it. It tastes good. But it's a short burst of energy and it doesn't do what they need to do. Buckthorn is one of the worst because it's Rhamnus cathartica. That name means it makes the birds throw up. After a half an hour, they eat the berries, these dark ones, and then they throw up. And that's the dispersal mechanism. The bird has moved in that half hour, the seed is then dispersed. But when you get a buckthorn invasion, it takes over everything in the understory. It's the only berries being produced, and the birds throw up all day long. So that certainly is not good for them. So what we've done in moving these plants all over the world is to create what ecologists now call novel ecosystems. And this term was coined by Richard Hobbs. He says 3/4 of the ecosystems of the world can now be considered novel. And by that he means that the organisms in those ecosystems are just meeting each other for the first time. They have no evolutionary history together. And what Richard Hobbs doesn't say is that that means they have not had the time to develop the specialized relationships that I opened the talk with, the specialized relationships that dominate nature. So we're creating something here, but it's not a natural relationship. Which means species are disappearing from these novel ecosystems. Now, if species are disappearing, we might want to ask the question, how many species do we need? And by we, I mean humans. Let's be selfish about it. Do we need other species to be okay on this planet? And when you're thinking about species disappearing, don't think about global extinction. I mean, that is the definition. They disappear from everywhere. But ecosystems don't function everywhere. They function locally. So think about local extinction. Think about the area on your personal property. How many species do you have today? How many were there a while ago? If you have fewer today, has that impacted ecosystem function on your property? That's the question. And in fact, ecologists have been trying to answer that question since the 1950s. Robert MacArthur, a very famous 20th century ecologist, was the first to offer a hypothesis about the relationship between the number of species in an ecosystem and ecosystem function. And he said, it's a simple relationship. As you increase the number of species in an ecosystem, ecosystem function goes up. Which of course means as you decrease the number of species, then ecosystem function goes down. And you can define ecosystem function any way you want. Very tough hypothesis to test. You have to have a number of controlled ecosystems, measure it over time, control the number of species in them. So he didn't measure it at all. He just called it the law of nature and moved on to something else. There were other hypotheses after that, the rivet hypothesis, the redundancy hypothesis. But in 2012, 3 different groups published simultaneously where they had actually tested MacArthur's hypothesis. They had controlled simple ecosystems over a period of 10 years. And fortunately, they all got the same answer, and it turns out MacArthur was probably right. It's a simple relationship. The more species you have in an ecosystem, the more ecosystem function you get. So, how many species do we humans need? All of them. We need all of them because we need as much ecosystem function as we can possibly get. It is the biodiversity in our ecosystems that are creating what we call ecosystem services. All of those services, they keep us alive every day. And the Millennial Ecosystem Assessment came out in 2005, measured the planet's ability to produce ecosystem services, and their unhappy conclusion is that we have already degraded the planet's ability to do that by 60%. That was in 2005, and I don't think it's gotten any better since then. That's the ocean, by the way. That's not a recycling plant.
Wow.
Well, why don't we let our natural areas make all the ecosystem services that we need? And you know the answer to this. We don't have enough natural areas left. This is the light map of the U.S. at night. This side of the country is us, our agriculture, and this side that looks, it's certainly less populated, but there is a cow on just about every single acre, yeah, really, we're talking about agriculture and people just about everywhere. Only about 5% of the country is relatively pristine. What we've done is taken the natural world and turned it into Gone with the Wind here. We've usurped all of these natural systems. And so what we need to do now is put ecosystem function back where we live, where we work, and where we play. It's going to be harder to do where we have agriculture, because we do need to grow crops. So let's function on land like this. We need to raise the bar about what we're asking our landscapes to do. In the past, we've asked them to be pretty, period. That's it. But now we need to ask them to support life, or life's going to disappear, to sequester carbon, to manage our watersheds, to support pollinators. And I talk about pollinators. We hear about pollinators all the time these days. And every time I hear about how our pollinators are declining, the reason we need to worry about that is the person will say, the interviewer will say, it's because these bees are pollinating our crops. As if that's the only thing that bees are doing. They do pollinate our crops. About a third of our crops are pollinated by animals. But they also pollinate 80% of all plants and 90% of all angiosperms, flowering plants. So if we were to lose our pollinators, if we decided we would start pollinating our crops by hand, which is what they're doing in China, by the way, it wouldn't be okay. We couldn't afford to lose 90% of the plants on this planet. We certainly would be gone. So losing our pollinators is not an option. We're not talking about just plain good land stewardship. We're talking about essential land stewardship. And I wish this were prioritized in the national debate. We've got an upcoming election. You can look at the top 10 thing people are worried about. Pollinators is not on the list. Biodiversity is not on the list, but those are things they do need to be worried about. There is a family that lives in this house. And if they're not producing all the ecosystem services that they need, they're going to have to borrow them from someplace else. And that's what we've done in the past. We have borrowed our ecosystem services from natural areas. But there's not enough natural areas anymore to support our ever-growing population. So where is this family going to borrow them from? They're not going to borrow them from their neighbor, because he's not producing any either. They're probably not going to borrow them from their township's open spaces. If their township open spaces look like my township open spaces, which is this, it's a paved path around this giant mowed grass, not going to work. We think if there's not a building on it, it's good land stewardship. So let's think about doing it at home. If we want to make clean water, this is not going to do it. Grass, lawn does not make clean water. It makes dirty water. And it encourages runoff when it gets sunbaked in the summertime. It makes dirty water, of course, because we're putting dirty things on it. We're putting fertilizer and pesticides on our lawn. So we need to reduce the area of lawn simply from a watershed protection perspective. If we want to sequester carbon, and we do want to sequester carbon, short-lived ornamental trees like Bradford pear are not the answer. These guys live about 30 years and then they fall over in the ice storm and release all the carbon they just sequestered. So you're back to ground zero. We need the big guys in here. We need that big bur oak holding that carbon for hundreds of years until we figure out how to pull the rest of it out of the air. And of course, by the way, we've measured, by the way, 90% of the suburban land mass in my neck of the woods is lawn. 90%. 92%. So we're talking about a lot of area that we need to address. Only 10% of the tree biomass that could be in suburbia is currently there. So we need a lot of attention to that. And of course, if we want to restore food webs at home, then again, Bradford Pears is not going to do it. Non-native plants. This is my neighbor's house. There he is with his 32 Bradford Pears. So, how have we gotten here? We've gotten here because we've come to see plants only as decorations. Why? Because they are decorations. They're beautiful. So when we go to the nursery, we look for a beautiful plant. Maybe it can be a screen, an anchor, a focal point, but it's all about aesthetics. We are not considering the ecological roles that those plants need to play at home. But we could find beautiful plants that also have food web value. If you don't have food web value, you don't have any other living thing at home, and that's not a functioning ecosystem. Are they supporting pollinators? Are they sequestering carbon, protecting the watershed, doing all of those things? So how do we do that? How do we create living landscapes at home? These are things we need to do. This is the most important thing we need to do. We need to create biological corridors that connect the natural areas that we have left out there. Those little habitat fragments need to be connected by the plantings that we have, again, where we live, work, and play. If we connect those isolated habitat fragments, they're not isolated anymore. If they're not isolated anymore, they're not tiny anymore. The populations within them are not tiny anymore, which means when they fluctuate, they won't disappear anymore. This is the single most important thing we need to do to end this steady drain of species from our neighborhoods. How are we going to do that? Well, I suggest we put some plants in the area we have in lawn. We have 45.6 million acres of lawn in the U.S. We're adding 500 square miles of lawn to the U.S. every year. Why are we doing that? Because lawn's a status symbol. And we are a highly status conscious species. We're not going to change that, but we can change what we consider to be high status. I was in Montana sometime, and maybe it was Wyoming, but I looked around and they didn't have big lawns. And I asked my host, "Where's your big lawns?" And he said, "Well, we only get 9 inches of rain out here a year." But he said, lawn is not our status symbol. I said, "Yeah, what is your status symbol?" And he thought about it for a while and he said, "Big belt buckles." So I think that is the answer. If we double the size of our belt buckles and cut the size of our lawn in half, we've got it. And of course, the plants we put in that area have to be productive plants. They've got to support the wildlife that we're talking about. This is what we used to do in the past. We built our houses, and then we put in a few trees, and we called that landscaping. A little flower bed next to the house. But then we were exhausted. No more landscaping, so everything by default became lawn. This is what we need to do in the future. We need to build our house and now figure out where we do want lawn. I am not suggesting that we get rid of lawn. Turf grass is the perfect plant to walk on to guide you through your landscape. By the way, I look at where my neighbor walks on his landscape and his family. His 10 acres, which is mostly lawn. You couldn't see that. Nowhere. They're never outside. Never outside. But let's say you want to get married in the front yard. You need some lawn there. If you want to walk to the backyard, you need a grass path, throw the frisbee, have a barbecue. Whatever you're going to do in your yard, that's where the lawn goes. Now you can actually interact with something outside instead of being inside all plugged in. If you convince your neighbors to do the same thing, now we've got that connectivity that I'm talking about. Connecting with the woodlot over here and the woodlot over here. Look, we still have our lawns. We still get to play with our lawnmower, so it will be okay. If we do this in half the area that's in lawn, let's make the math simple and say we got 40 million acres in lawn, we can create a new national park that'll be 20 million acres in size. We're going to do it at home, so we'll call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, plus Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands, plus Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. You add up all those parks, still less than 20 million acres. So let's do that. Let's make the biggest national park in the country, probably the world, I think. Let's take areas that look like this and turn them into this. Notice, we have not moved out. We're simply sharing our properties now. We're abandoning this idea that humans are here and nature's someplace else. Now we're going to be together. Let's take these square things. Let's put some trees here. There's actually a high-end house over here. I should have included more of that in the picture. But this is a productive property, and people live there. Maybe you can actually have a part of your yard that has no lawn. A very productive little prairie scenario. The bees will certainly love you for that. This is a mulch sculpture. It's down the street from me. And of course it demonstrates that you can't use native plants formally. Except nobody told the folks in Indianapolis, this is a formal planting in a park right in the middle of Indianapolis, all native plants. Of course that's one of the myths associated with native plants. You certainly can use them formally. Formality is a function of the design. It's not a function of the plants that you actually use. This is a corporate landscape that invites the employees to come in at noon to get sunburn. It could be a landscape like this. And there's really interesting research that shows if you spend just 15 minutes in a landscape like this, there are measurable medical benefits. Your blood pressure drops, the stress hormone, your cortisol in your blood drops, your cancer is cured, you don't get divorced anymore. All kinds of wonderful things happen. And I'm not kidding. The research has shown that you get the same medical benefits that you get from intense meditation, and that has been shown to boost your immune system. So you've cured your cancer. And also, your attention span is restored when you spend a peaceful time with nature. We're bombarded by information from the time we wake up in the morning till we go to bed at night. We come home from work exhausted, and we yell at our spouses. That won't happen anymore when you spend a little time with this. But you can't do that unless you work in an area like that, or unless you live in an area like that. Going to Yellowstone 2 weeks in the summer is not going to work the rest of the year. You have to do it every day. So I'm going to put mental health up here as another ball that a lot of people are interested in. Not just mental health. You put a tree outside of a classroom and test scores go up. Nobody knows why, but it's happening. You can repeat this time and time again. That same tree outside the hospital room and the patient gets better faster. So we need to pay attention to this. Also, entertainment. When you create landscapes like this, you can add 3 things to your life that may not be there now, or at least to your property. Surprise, anticipation, and entertainment. You can't walk into a landscape like this without seeing something you didn't expect to see. That's the surprise value. Maybe you see the spun glass caterpillar, which to me that's the coolest caterpillar in North America. Maybe you see the puss caterpillar, which is, how cute is that? Look at his little top knot there. Or the evening primrose moth. That's what it looks like, but really you'll find it buried in the primrose flowers during the day. Very, very beautiful. Maybe you'll see this dead leaf, which turns out to be a caterpillar. That's the larva of the showy emerald. Maybe you'll see the fawn sphinx. I go to talks all the time, and people show me beautiful plants, and they say, this will knock your socks off, this will knock your socks off. That knocks my socks off. Now, I admit, my socks are easily knocked off by caterpillars. I looked out my bathroom window. Everybody likes my bathroom window. I look at it last summer, and there it was on my ash tree. This is one of the species that will disappear when ashes disappear. Only the second time in my life I have seen it. But if you don't like these sphinx moths, look who does like it. It's a favorite food of our thrushes. We can't afford to lose them. Maybe see an interesting behavior. This is the red-spotted purple. It's female. She's going to lay an egg. She'll land on her favorite host plant, which is, at least at my house, is black cherry. And she inches her way down the leaf till she gets right to the tip, touches her abdomen to the tip there, and leaves her little egg. That's where you find red-spotted purple eggs. And she will do that right in front of your face as long as you're not waving your arms. Maybe you see the Sphinxicampa caterpillar. How cool is that? I show this to my 3-year-old granddaughter. No, I show it to adults. And they say, ooh, is it going to sting me? But my 3-year-old granddaughter says, ooh, is it tickly? It is not going to sting you, and it is tickly. Anticipation. Throw away your calendar. You can anticipate when the seasons change by what is happening biologically in your yard. We know spring has come when the woodcock shows up, and not before. And we get to anticipate that. I ask Cindy every day, have you heard the woodcock? Have you heard the woodcock? No. Then yes. And that's a great day because it renews our hope. No matter what you read in the paper about all the terrible environmental things happening, the woodcock still comes. So it's a hopeful message. The toads still sing on time. The white-lined sphinx still comes to the evening primrose the 1st of August. The juncos still show up in the fall. So nature is still happening, and that's pleasing to us. Entertainment. This is a Bottlebrush Buckeye. I walked by 2 summers ago. 17 swallowtails flew up. You can't walk through a cloud of 17 swallowtails without a smile on your face. You just can't do it. But does that mean your yard has to be 100% native? No, it doesn't. There is room for compromise here. I just want people to understand what each plant in their yard is contributing and what it's not contributing. I always use Crape Myrtle as an example because we got a lot of them in this country. You got a lot here. As you move to South Carolina, it's the only plant left in the state at this point. Why? Because it's beautiful. It's got exfoliating bark, any color you want, and it's the right size. So we use a lot of them. What is it contributing? Well, it does contribute some pollen and nectar to our bees. But for food webs, just about nothing. So I think about what, when something's contributing nothing biologically, but it's beautiful, that reminds me of a statue. But the question is, how many statues do we want in our area? One or two is okay. But when you find every single plant is a statue, you gotta rethink it. How do you know when you've succeeded? Well, there's countless ways to know when you've succeeded, but this is a question I get a lot, and that is, where are the fireflies going? You guys have fireflies out here, right?
Really?
Oh, we used to too. Fireflies aren't flies at all, they're beetles. This is the adult. And of course they talk to each other with a lantern and have little light signals. But as larvae, they are predators in leaf litter. If your fireflies have disappeared, you've probably raked up all your leaf litter. You've neatened up to the point where you've got bare ground and there's nothing for them to live in or eat. Or you have chem-lawn, so you poison them. Or you have lights on all the time, which messes up their communication. If fireflies come back to your neighborhood, you're doing something right. If you have holes in your leaves, this is a shingle oak leaf, and it has passed on part of its energy to some other lucky thing. Probably, well, definitely a caterpillar, which then is feeding a bird somewhere. This tree has now shared some of its bounty with other living things. That's a sign of success. It's not a signal to run and get the spray can. Greg Nace at the University, or the Pittsburgh Botanical Garden, calls this holistic gardening. I think that's a good thing. And of course, if you have breeding birds in your yard, you're doing a lot of things right, because there's no way that this bluebird can pull off a clutch unless you have a lot of food that you're producing. So these are reasons that have all been suggested of why we might want more native plants in our gardens. Some people say, well, we should do that because then we'll have a sense of place. And that is true. If you're a good botanist and you understand the plants that ought to be in your area, and you can travel around the country and get out of the car and recognize different biomes, you can appreciate a sense of place when those plants are present. But I'm convinced that nobody cares about them, and it doesn't matter where you are, they all have the same few species of Asian plants, same small palette. So I don't think sense of place is going to convince anybody. I don't think we can argue that native plants are prettier. Some people do. We do have beautiful native plants. We've got our dogwoods, we've got beautiful trilliums, we've got our bluebells, but we've got that Crape Myrtle too. There's a lot of beautiful non-native plants out there. So I don't think we're going to win that argument. Now these three have actually been applied to me, that I like native plants just because I'm nostalgic for the past. I want things to be the way they used to be. I oppose change. Don't I know that ecosystem change is normal? Yes, I do know that ecosystem change is normal, but I also know that ecosystem change is typically very slow, and that we are changing ecosystems now much faster than the animals and plants within those ecosystems can adapt to those changes. So I don't oppose normal rates of change, I do oppose abnormally fast rates of change. And it's not because I dislike foreigners, that's called nativism. I like native plants because I like ecosystem function, and we're not going to get ecosystem function without them. And I want to, well, before I do that, yes, we can save nature only if we learn to live with it. That is true. We're all going to have to live together. I want to show you how easy this can be. I'm finally going to end here, but with this story about the Italo Butterfly, the homeowners, neighborhoods in South Florida have accidentally saved this butterfly from extinction. It's a lycaenid butterfly, only has a range in South Florida. It's beautiful as an adult, beautiful as a larva, beautiful as a chrysalis, and it is a host plant specialist, an extreme specialist. Eats one species of plant, a native cycad called coontie. Now coontie, unfortunately for coontie, had a lot of starch at its roots. The Seminole Indians knew that. They used it as a source of starch in their food. When the settlers came to South Florida, the Seminoles taught them, hey, coontie's got a lot of starch. So the settlers used it for food too, but then the settlers said, hey, we can make a starch industry. At the turn of the century, the starch in your collar came from coontie roots. When they did the, I think 1908 or 1912 census in Miami, 80% of the people, the residents of Miami, listed starch gatherer as their occupation. And they did. They gathered all the starch. All the coontie was eliminated from the wild. There were a few plants in gardens, but otherwise it was gone. So of course, if coontie's gone, then the Italo's going to disappear because it's the only thing it can eat. When we came up with the Endangered Species Act in 1974 or 73, there was a desperate attempt to find some Italo populations so they could get it listed as an endangered species, so they could get some federal funds to try to save it. But nobody could find any. So instead they got it officially listed as extinct. But about that time, the horticultural trade recognized coontie as a valuable landscape plant. It's a low-growing evergreen shrub that does well in the sandy soils of South Florida. So they started to promote it. And plantings like this are now common. And guess who showed up again? The Italo has come from who knows where. There must have been a population in the Everglades. And it is now colonizing those garden plantings of coontie. Coontie's still gone from the wild, but anyway, the Italo is back. So what I love about this story is that this truly was an accident. They never got that species listed as an endangered species, which means they never got one dime of conservation money, which is good, because we don't have one dime of conservation money. The only thing they did was add one species of plant to the palette of plants used in South Florida landscaping, and that was the coontie. And the Italo saved itself, which shows how powerful a conservation tool this can be. If we can save the Italo without even trying, think what we could do if we made conservation a conscious goal of landscaping. I think it's going to work because nature has proven to be really malleable, really resilient, really forgiving. It is not endlessly forgiving, but I do think she will give us one more chance. Thanks very much.
Thank you so much, Dr. Tallamy. That was, as usual, wonderful, and I can see that sawtooth oak going. Sawtooth oak is from China. Yeah. I mean, I thought an oak was an oak. You know, whenever I bought it years ago, you think an oak's okay. We still have books, and Dr. Tallamy will be back there signing books for us. And thank you so much for coming to Tulsa. We appreciate it.